Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forums, and everybody else just calls me Damon. So, the third Sundown that I got, a little bit beat up. It's definitely been installed several times and everything, but a big Sundown Audio, the SAZ, that's supposed to have been their pretty tough line, 3500D, so it's a good big amp, lots of power. Lots of boom. So this is the third one that I've got from Shane. Again, thanks Shane. And he was nice enough to give me some notes about what he knows. Like I said, I bought some amps from him. Trying to get a hold of a few of these, and so he had a few personal ones and he was willing to sell me, and he's an awesome guy. So shout out to Shane. He knows who he is. So while I'm taking this off, we'll read the notes. It says, I got this one in a trade. It looks like the pulse width modulation card needs attention. I'm guessing they couldn't get drive. And then he's got some notes over here of what he was going to use in it, I think. So we got a power supply. He was going to put IRF 3205s. Yep, 22 ohm gates, 470 ohm pull downs. He lists the two drives that he has been using, the 2N6034Gs and the BD139s. I've got the BD139s and the BD140s for certain. I may have these 6034s also, not sure. And then the outputs were the 24N40s, and it's driven with the IRS 21844 chips. Sorry, there's glare. I'm still working on my lights. I've got some lights that I'm going to try. It will require me turning out my garage overhead fluorescents and trying to use a diffused light from each side. But I got to get my garage a little bit cleaned up to do that. And that's not going to happen until the weather is a little bit nicer consistently. Because every day that we get that's nice, we've been trying to get something done on the outside. So let's see what we got here. Well, we got a big old amp missing every FET over here. Looks like we got some FETs over there. The rectifiers in the middle. All the outputs are out. A little package here, which appears to be all the clamps for the FETs. So let's hope they're all there. Screws, clamps, that's all that is. Screws and clamps. Okay. So 6 little power supplies. We'll have to check these FETs and look at them, do a little cleaning here. Nothing in the output section. Got all the rectifiers, got the voltage regulators on both ends here. This is the driver board for the output section, and it's got those chips. Anytime when you use that 21.8, what is it, 20, I have to look at it every time. Yeah, the 21844 chips, which has got two of, one right here and one right there. Anytime the output blows, you have to replace those. They are they work just fine, but they're extremely delicate in the fact that if anything goes wrong, they die. You can actually screw them up installing them wrong. You gotta take extra care. So I'm gonna look here. We're gonna get a baggie for screws and other things we take out. There's the screws. I'm gonna go ahead and put all. Oh, there's the board standoffs and those screws. I'm going ahead and dump all this in here. Make sure I didn't miss any. Alright. We're all good there. I like clear baggies. I bought just great value brand multicolored ones. It's yellow, green, blue, and red. It's kind of nice to have different colors. One of these days I might get really smart and like use blue for Rockford or blue for Class D or something like that. But anyway, I'm going to try and take these screws are all off except for 2 on the end plates. So give me just a second here. We'll see if we can clean this or get this board out. I'd really like to get this one going. Oh, looks like they've soldered in some goofiness here on the power supply board. That's what he was talking about. That may be a little bit of it. So get that end plate off. Oh, we got speaker terminal screws that need to go down to get out of the way. Will they go down? Are they too long to go down? Yes, they are. So out they must come. These are going to get replaced because they've been replaced already. Somebody's put different ones in. They put these big black ones in. I'll put a shorter chrome one in it. We might have to order parts for this. I don't know. I got the end plate off. I'm going to go ahead and stick those screws in that bag, and then the end plate will go with the back plate. Now, in theory, unless he's put some screws back in the middle, this might... Oh, he's got some screws in the end plate here. Okay. Turn it all the way around. Bad when the amp's almost too big for your bench. I did some 7Ks that were just monsters, and they were even outside of the heatsink. They were just almost ungangly, and they were a single board. They weren't split like some of the big Sundowns are, and some other big amps where you can unbolt them and split the board in 2. Those were straight up one single giant solid board. Got everything there. Aha. I see a screw holding the board in. Well, I say that they were just like this in the fact that they were all bored together, but their preamp board was separate, and so is this one. You can see that one unplugs there, and that's kind of nice. It was really helpful with those 7Ks because they had problems in the preamp boards, and they were just, there was 3 of them, and they just had a huge assortment of problems. And try to get this into my lap without dropping it. Ugh. So I can get this board up here. And now we're putting the power supply on this side because that's where my power supply stuff is, but we'll set that big monster out of the way. Okay, and we can set the preamp board gently out of the way for now. We're not ready to do anything there. So, let's see if I can get that there and go zoomy zoom without shaking you too much. See if it'll come into focus. Yeah, there we go. Move this just a little. They've added on a capacitor, and who knows what else they've done there. Onto that board. We're going to take that board out. We'll stay zoomed in on the amplifier here. So we're missing all this side power supply FETs. This side, Looks like it's got 3205s in it. All the drive transistors have been cut out. So that's what he was talking about on that. So we need to get this board out and clean those up. And also, we need to go ahead and check all these 3205s. Paper towel. I'm going to clean this up. So off camera here real quick, I'm just going to use the if I grab it here, super duper desoldering gun, the magic fart gun, and pull that. I may have to pull some of these FETs. What we'll do, just like with anything else, you just put your multimeter in continuity mode and you're checking from leg to leg. And that's okay. You heard that beep, but it went up and away. That was a cap charging, so that's okay. So I'll check all the rest of them. I'm going to clean this thermal paste up just so I don't make a mess everywhere. Because I always put fresh thermal paste on them unless they're like brand new. But I'll get that cleaned up. I'm going to solder suck out all the where all the drive transistors were. Make sure all these holes are good. Make sure these FETs are still good. Get this board out, and it has a bunch more drive transistors there that are missing. Wonderful. And then I will also check all of these gate resistors on both sides, and the pull downs. He listed what they actually were supposed to be. And that'll get us to a point where everything's taken apart. We'll look at this board. Hopefully you'll be zoomed in when I bring you back, assuming none of these are bad, and I check all that other stuff and we clean it all up. So I'm going to do that off camera because that's just going to be solder sucker. I could fast forward it, but that's not really showing a whole lot. And we'll get to it. All right, see you in a little bit. All right, so we have cleaned out all these holes with the fart gun. I also cleaned up these FETs had just been cut off, so I cleaned out all those holes. And then I removed the power supply card, which has obviously had some kind of issue. And they've tore off this surface mount capacitor and then just used a couple legs to zap it back on there to try to work on it. So I went ahead and pulled this because I don't have this magic of YouTube. Hopefully one will come in, but I've got me a little terminal strip here that this can plug into, and I may build me a little test board to be able to test it separate from here. And if I do, I'll draw that out and we'll build it up. I got to do a little probing to see what all these pins are. I've got a few of them done. As with everything, I got me a notepad. So there's 6 sets of power supplies here. And so there's a power supply, you know, all these. So we have a group, a group, a group, a group, a group, a group. And that's what I cleaned all the holes out of, all the drive transistors. Got me a whole bunch of drive transistors right here. And then I started probing them. Now, let's see if I can pull up. Ooh, that's over my recording thing. It. And yeah, I think it's this video right here. Have to be. Yes. Let's pause it. So if you go to my PPI right here, PPI Power Class 1800.2 Amp Repair Episode 3. we talk about how these transistors are set up, and that's exactly what we're doing here. So if you go watch that video, I've just labeled these the way they needed to be based off that exact same video to know what they drive. We measure from B plus. Oh, you can't see B plus. I gotta slide the amplifier down a little here. From B plus to find the ones that are got B plus on them, and that's what I've done here. And the ones that have negative, so I know which ones they are. So going from the negative, that wire's about had it. That's going to have to be cleaned up and fixed. And then also, along with that power supply board, I did a little probing. And I've got them kind of labeled out here to the side, starting with pin 1 down to pin 11. And I have found the remote, the ground, the B plus, and the 2 drive circuits. So I leave 6 pins I need to identify. They're most likely all going to be for different inputs to the little comparator right here, and to the comparator on this KA-7500 for shutdown and stuff. Shutdown or turn on, some measurements of that sort. So, like I said, I will probe this. I'll try to do a little drawing down here. We'll maybe build a little test board to test these things outside, so I have it. If you watch, I don't know if it'll be released by the time this one comes out, my bass knob series, where we're talking about all kinds of different knobs and stuff like that. We use some perf board to build up a bass knob, and so that's what I'll probably do with this, and make me a little jig that I can just clip power on and take some measurements, so that I know these cards are working right once I've fixed it and repaired it. Much easier than trying to fix it while it's mounted in here, because when it's mounted here on a big long amp like this, it's really hard to get in there and remove components and solder them. So if we build us a little test jig and just set it aside for always doing the style that's got 11 for this style, of course we'll have to label this and make sure that anything we ever stick there, but it's kind of got a little part number on it. We'll put that on there so that maybe we can know, and if we find any that are different part number but they're exact same layout, I'll take pictures and pictures of the back of the board, and the exact same pin layout. I can add those on there with just a little flap of paper taped on it, so I know which all ones it covers. And that's how you kind of get into getting faster at fixing these. If these have a problem, you would just unsolder it, put it onto your test board, troubleshoot it, figure out and make this thing working right without having to try to fight it in here. Now, every now and then you'll get something easy and it'll be, oh, it's just this, always this transistor or that one there, where it's up on a corner and you might be able to get to it, but don't guarantee it. Plus it's just nice to have a little test jig when you need to troubleshoot it. Now, I don't trust anything on this one because of the botchery that's already happened. I mean, there was tons of botchery on this amp. It was a trade-in to my buddy. Who knows what my buddy did to it? I don't care. We're just pulling it apart, stripping it down. We'll get that board working, which will provide us drive to all these. We'll stick those in, which will then provide us drive to the transistors. Now, the last thing I'm really looking for is I really don't have to install any FETs over here, because these FETs all tested good. I'll make sure, some of them are missing their drive resistors. Not sure why they took them out. But, and my buddy was backwards when he wrote it. I'm sure he just glanced at it. But it's 47 ohm gate resistors, 220 ohm pull down resistors. But as I look at these 6 transformers, I notice this one and this one have the extra single windings on them, which means they're going to be the ones responsible for producing the plus and minus 15 volt rail, and possibly the help out with some of the 12 volt and 5 volt stuff. Some of that's referenced from the main rails, so like you have 12 volts above the negative rail and stuff like that. But so we'll want this one at least powered up, and maybe this one over here when we first are doing it, and we won't have to worry about these. Technically, we wouldn't have to worry about these, but you're always looking, if you got multiple power supplies, the one you would like to power up, or the ones on, maybe in this case, would be the ones with the extra winding to provide your additional voltages down here. So if I can slide this back forward a little bit. Down here to the, one of these is going to be, at least one of these is going to be plus or minus 15 volts. The other is probably 12. Here is some rectifiers right here for this one. These are not, and these, oh, I see on the board it says these are 12 volt ones right there, and these are 15 volts. So these extra windings right there will be going to these rectifiers to, and use these caps and these regulators to make the plus or minus 15 volts that give us the plus or minus 15 we need for the opt amps here on the preamp circuit. So that's why it's important to power that up. Make sure we got good voltages everywhere else. We're still going to have to rebuild this card. I got to take it out. But I can remove this card, but we can get this plugged back in once we have that running. And then it's going to let us know, you know, power protect, because nothing in the outputs will be running. There is a possibility the shutdown over here may not get its feedback, and so we'll have to look. But most of the time these boards, if this is 100% standard Korean design, will run with the outputs all out and with this card out. And like I said, since something happened with the outputs, this card has to come out for me to replace at least those and make sure nothing else seems bad. We'll put that card back in. We'll look for a low side drive. As long as that's in, then we can solder it in, and then we can determine the banks, which that looks like, since we got 2 coils out and 2 relays out, we probably got a high side and a low side on each side. So we'll end up needing 4 FETs to do the initial test, and we'll go from there. And so I'm going to pop out, work on this little board, magic of YouTube stuff, because I'm waiting on some parts. I do have some 47 ohm resistors to finish fixing up this gates and making that's all good. But the big thing will be fixing that power supply card first, getting it in, and then we can actually see the drive on these pads. And then we can install these, which will put drive out to the FETs. And since we already have some FETs in, and I may add the ones in over here to make sure we get those voltages. Measure all that, all good. I'm blabbing on a little bit, but just trying to explain my thought process. You get part of the power supply working. The important part is to get the secondary voltages all out too also, so you can check all them. Once that all tests good, we can go ahead and finish populating out the main power supply board and have it fully operational. Check the preamp area, and then fix this board, and then we'll check for drive, and then we can put the FETs in, test. Everything tests good, put them all in, and this thing will be up and running, hopefully. And if we run into any other fun and exciting problems, I will be sure to let you know. But I'm going to get to building that jig for this. And like I said, magic of YouTube. All right, see you in a minute. Okay, so by probing around on the board, we have determined that these pins, here's the remote ground, B+, and the 2 drive circuits. So what we need to do first is fix this screwed up cap. I've got a replacement cap here, so let's see if I can zoom you in without screwing everything up. Here we go. Put you right there. I'll get my glass. Ooh, my glasses are dirty. Got the soldering iron heated up. Let's see how much damage happened on the board when they tore this cap off. There's one leg off. There's the other. Looks like this pad got tore up pretty bad. This pad looks to be okay. Need a little wick. You got so much solder glubbed on there that I don't know. Oh, I've got you out of the picture there. I don't know. Let's go ahead and get this one cleaned up. Here's a pepper dog wandering back there. Okay. I think she may want out. Give me just a second to fix the dog. Okie dokie, the puppy's out. So what we got, oh, and that just came off. Okay. So what we had, if I can get centered up here where I'm supposed to be working, was a pad. There's the pad. And if we get up here closer, let's clean it a little here. Yeah, a little cleaning going on. Alright. So, we can get a focus. There we go. We had a pad right there. And it looks like it was connected to this trace going to this diode, and then down to this trace, which feeds all these others. Now, the way that diode was set in negative was over here, so we can confirm that with our multimeter. Look at these. Those of you, we're just going to have the multimeter on continuity. So we said on our little drawing over here that we made, pin 5, 1, 2, 3, 4, 5 is negative, and that is true. And 6 is the B plus. Okay. 1, 2, 3, 4, 5, 6 goes to that pin, goes along this trace up to this via. That via is right there, so I'll bet 6 goes 1, 2, 3, 4, 5, 6. Comes up this via. Yep. So that's going into that transistor, so it's got to get turned on, so that means B plus will come out here when that transistor is turned on. Does that go to that diode? Yes, it does. So when the transistor gets turned on, most likely by the remote, power flows through that diode. It went into this pad to smooth out in the ruined capacitor, which also jumps across there. So we need to, what happened to the pad? Oh, there it is. Multimeter set over it. So we need to scrape back this trace is already pulled up a little bit. Let me get my magnifier and give it a look-see. Yeah, okay. Let's see if I can do this. I've got a magnifier on order that's supposed to let us do some of these things. Oh, here comes the pepper dog. Hopefully better than this. Alright. So there's a trace right here that we need to expose copper on. May have to get my razor knife. just knocking that conformal or that solder mask off. Maybe coated too, but we gotta get that solder mask pulled back. And we gotta do the same thing right here. We're gonna have to fix this connection. It's coming off a little better now. Got a sharp point on here. There we go. Guess can't hardly see that. I need to make sure I'm keeping an eye on what the camera can and cannot see. That looks pretty good. Take a soldering iron. We can tin that up a little bit. Making sure you can still see that. So with this right here. Alright. So what we need is our solder pad back. In place. And we need, got a little wire here, some wire to go across that too. Give it a little tweak. Snip this off. Back in, but it's not causing me problems. So we gotta make sure we're in camera focus here. Okay, so we place the solder pad. We've got a little bit of wire here, and I'm gonna fudge this wire. I'll tweak it a little more. I've doubled it up because that's the main power circuit. Oh no, I flicked the solder pad off. Reason why we want the solder pad on there is because we need this back half back here to solder the cap on. That's just a smoothing cap for the power. And so we're going to fudge this wire to the side opposite of the cap so that hopefully we have enough pad back here to solder the cap to. See how this all goes. I can just make an absolute mess of it. I may say screw it and fast forward all this stuff so that you guys aren't so bored to death. Oh, that thing just is will suck up onto my soldering iron. Where'd it go? Oh, there it is. All right. Drop my razor knife. If that don't work, we're going to put, oh, did my big fat head get in the way? If that don't work, we're going to put some solder braid across there as a new pad. Alright, that's looking pretty good. So we're going to stop right there for a second before we cut anything. We're going to take a continuity test from this. Alright, we have continuity across there. So let's snip this off. And then I'm going to smash the edges down a little bit. We have to get a little pair of pliers to do it the way I want it. There is a trace running right there underneath that edge. I want to snip that back a little more. If you see, there's a trace running right here. I don't want to melt through the solder mask. So I'm going to get that a little further back. Now, the question is that still connected a little bit? No, and that's what I thought. So let's see if when we flow this down a little, there we go, it all sets down. Let's see if that all grabbed. If not, we can always grab it at the end of this diode here. That is right there. Alright, we got continuity there. And we should have continuity. No continuity at the top of that resistor. Oh, I keep forgetting I gotta be right in a certain spot for the camera. I'm getting used to it, guys. It'll take me a little bit. Let's see if that got it. Should have continuity to there. We do, and we should have continuity to there. We do. Alright, so when I go to place this cap here, I'm going to pre-tin this front half. You can't see the cap, so I'm going to pre-tin this positive side just a tiny bit, so that hopefully that'll just flow right on there. Okay, that looks pretty good. Got knocked out of the way here, so we're going to go check continuity again. We got it there, and we got there, just what we wanted. Now we can check and see if from this diode, we're going to touch the back leg of the cap, and I can watch it charge up a little bit. So let's get in the back side here, right there, and solder up the negative post. got it. We'll go from the 5th one over. 1, 2, 3, 4, 5. Can touch that. That looks good. It looks like we should be able to get. Yep, I'm getting a cap charging. All right, so we're going to double check. Diode. That's good. Over to here, and we're on that cap. Wonderful. So to add some strength to that little bit right there, we're going to put a little solder mask back on. This is a UV curable solder mask. I've got a laser somewhere. There it is. I see it. I just need to squeeze a little up here. Oh, that's a whole lot. I'm just going to get a little UV solder mask. I'm going to put that on there. To help hold that all in place. I'm going to cure that. Clean up my stuff here. Pepper dog is wanting attention. Do you all have attention wanting pepper dogs? So here's my little UV laser. We'll see how that does, and we're going to cure this all up. Of course, I'm not going to make you sit here for the full 5 minutes. I'm going to set my little clamp up and just have it beam right on there, and I'll move it from here to there a little bit, but we'll get its skin over. And then I'm probably going to take a little bit, let me show you here, of E6000 and put a dab right here, and maybe a dab on the other side of that capacitor to help make sure that there's no stress on this repaired section that we've got. And as soon as I get this cured and get the EV6000, let it cure, it doesn't take very long, we will then move to phase 2, which is testing this. I got a funny feeling they broke that cap handling the board accidentally, and then wondered why they had no power. But remember, B plus we said goes there. It went on a trace on the back, went through here, which this probably gets turned on by the remote to provide power everywhere else. So they were missing, well, it goes through that diode. They were missing power to everything, so they weren't getting any drive. So they may have tore the whole power supply down for no reason, thinking they'd fixed it with this bodge job. That's a MyMate Vince or a Coder or any of those guys over there. An EEV blog, David EE blog. It was a real bodge job. It's a bit dodgy, and so we will see if this does it. So what I'm going to do, I'll zoom you out here while I'm doing this. We got our notes. I've got my old experimenter's board, and this I got from my dad. Actually, he had to long eons ago, back when wheels were square, he had to take a basic electronics course to finish up his stuff for some diesel mechanics stuff and maintenance. It may have been for maintenance, actually, more than it was diesel mechanic stuff, but he had a little class and they had this in it, and so this is the one thing I have left from that class that he took, and I've used it all my life that I can remember as my little experimenter board. I got a bigger one also, but I've still kept that thing, and it still works. And so we're going to plug this into the experimenter board. I got some test leads here that we can plug in also. We'll make one ground, one remote, and one B plus, and then we'll measure on the legs. We said, I gotta look over here on my paper. legs 8 and 9 should be the drive outputs, and I verified that off the board. I could actually trace it off this KA7500, but that KA7500 is the exact same pinout as a TL494 or a TL594, so that's kind of handy. So this, let's see if that's skinned up a little. Oh yeah, it's already starting to get good and hard. So as I've been blathering, I may fast forward through some of this. People want to get to seeing the works, but I'm going to finish this up, and then, like I said, we'll use a black here for, we got ground, remote, and I got a positive one here for B+, and we're going to see, and then we'll use the scope up in the corner here to see if we get drive pulses out of here. And as long as we do, then we know we can install this back on the board, and we can start putting the drive transistors in. And by the time I come back, I'll have played with the dog for a minute. She's just dying for my attention, so I will give her a little love, and I'll see you guys in a minute. Okay, so instead of using the breadboard, plugging it in, plugging these wires into there, once I got my little test jumpers out, I kind of realized that I could just have my power here. This is positive and negative. And then I've got the remote in green, positive here in red, negative here in black. We're going to power up the little board now that this is all set up. And then we're going to take readings off pin 8 and 9 on this drive board. And so you'll see that up there on the scope, and I'll zoom in on the scope once we do it. So we're going to power it up. There's a couple different things we can check for. I've got my multimeter here. If I can untwist it from my power wires. There we go. Hook my negative lead up there. So we want to check pin 1 and 16 compared to pin 2 and 15 corresponding here. So you can see the voltage. So we're going to look at pin 1. I'm going to make sure I got my glasses on here, so I'm connecting where the darn. We're going to double check and make sure we're feeding it 13.75. That's, or 5.7. So pin 1, no voltage. Pin 2 is 2.4. Pin 16 is no voltage. This is probably 5 volts, yeah, 4.96. So pin 1 and 16 need to be lower than pin 2 and pin 15 for the chip to work. So we have that, and the reason why that's important to check the first time here, this is on the KA7500 or the TL594 or the 494. They're exactly the same chips. You can replace one with the other. But we needed to see if we needed to drive anything else into these other pins, which then we would have used this breadboard to maybe make a little voltage test thing, divider or something, for a signal to say that it's okay for this chip to run. So now we should be here at pins 8 and 9. So it's going to be that pin and that pin, and I'll show you. Let's just go ahead. Here's the voltage on 8, and see my meter. There we go. About 5.9. About 5.9. Now this is just a DC meter setup. Now watch what happens when we look at it with a scope. I wanted you to see that average voltage, because you can look to see if there's output. See right there? Hey, there's drive. Let me switch to a bigger picture of the scope there for you. I'm going to touch the pin, and there you see the drive, the square wave. Now that little extra rise on there, this chip's driving nothing. It's just producing a square wave, so it's got a little overshoot. That'll be fine. That should go away when we do something. But I checked both pins there, and so that's got it. But you can kind of check it with your multimeter, and you should get about, depending on how the drive circuit's set up, about a 5.5 volt, almost 6 there. out. But that won't tell you if that, you know, if it's low. If it's like 3 volts out, that probably means this wave is all distorted. That you see there. And is no good, but you really can't see whether or not it's making a good square wave without a scope. So it looks like that's all good. Let's go ahead and shut the power off. We can hook up this board back into the amp, and then we can quickly check. I'll do that off camera. It's just going to be insert the board and solder up the bottom here, and then we can check and make sure we have drive on all the pads, that there's no problems there. And if there isn't, then we can install all the drivers to get us drive out to where the FET gates are, and then we could install power supply FETs to get the power supply up and running. Once that's up and running, we can rebuild the output driver card, and away we go. I'm probably going to end this one here real quick. So we'll start the next one off checking for these signals out on the main board. Look for part 2 coming up shortly. And like, comment, subscribe. I try to get to the comments. Sometimes I see the comments and I'm going to reply back to them. It just takes me a little while. I hate doing stuff on my phone. But if it's a super short comment, then I can reply on my phone. But normally I want to get logged in and at the computer and sit down and make a semi-intelligent response, or I try to anyway. So comment, just, you know, if you don't get a reply back quickly, I try to get to them all. I read all of them, and then I try to reply back to as many as possible. So, but I think we got this fixed. It was probably just a power issue, not powering this up, so why they lost all the drive. Maybe why they tore out all that other stuff. So let's get this back in, and I'll see you in part 2. And like I said, we're getting close to 1,000 subscribers. It might be by the time this video is out. Who knows? Try to do something special. I'm not sure what yet. Just been super busy at work. It's a tough time to get 1,000 subscribers when you're so busy. But I'm very, very appreciative of it. And thanks everybody. And stay safe. And I'll see you next time.